Good day, viewers. You are welcome back to my YouTube channel. We are still under the concept of set operation. Actually, this is the third part of this practice problem videos under set operation. So this is question number 5. Okay, so we're given this information on the board and we're asked to find the whole of this. So let me read very quickly. The question says, let U be this, A equal to this, then B, let B be set of S. This curly bracket means set of. So set of S such that S is a positive integer and S cube is less than 3. Then set C is this, set D is this. And now we're asked to find the whole of this. That is find I, find II, find III, find IV, which is this, then find V. Very important. So what we're going to do now is to carefully solve for the whole of this. All right, using this information given to us here. But of course, set U, which is the universal set, is very clear because this is just nothing but set of numbers from 1 to 20. It's just very clear. And set A again is just straight up, which is a listing method. Of course, you can revisit my video under set presentation. Under representation of set, which we have the set builder method and the listing method, or also known as the roster method. So set U and A are given in listing method. Then set B is given in form of a set builder notation or set builder method. Then set C and D are also listing method. So all of these sets given in listing method are quite simple to understand, but these ones given in set builder notation is a kind of tricky, but we're still going to do it. So let us write out what set B is in listing method. All right, let us write out set B in listing method. So what do we have? Set B says that it is set of S such that S is a positive integer, number 1, and whatever S will be, its cube will actually be less than 3. So positive integer, first we are going to know that positive integer is actually from 0. Now because if S is 0, if you take the cube, if you say 0 raised to the power 3, it is still 0, which is less than 3. So 0 is among here. Now another positive integer we're going to take is 1. 1 raised to the power 3 is 1, which is less than 3. So 1 can be among. Another positive integer is 2. If you take 2 as a positive integer and say 2 raised to the power 3, you have 8, but 8 is not less than 3, so 2 is not going to be among. So it therefore means that set of B is actually 0 and 1. Okay, now of course we have set C, we have set D, we have A, we have universal set. Now having these sets, now we can now find whatever thing they are asking us to find. So let's start with the first, I. I says A complement intersection D. Now for A complement intersection D, we need to first of all find A complement. Now don't forget what I explained in my previous video, what A complement means. So if we are given set A, of course in this case set A is set of number from 1 to 5. And now if we want to get the complement of A, it will be all the numbers that are in the universal set, but they are not in the given set. It's as simple as that. So it means that whenever you will be asked to find the complement of a set, you must be given the universal set that you are going to use to get the answer. So here we have the universal set and we have the given set A. Hence, looking for A complement, it will be the set of numbers that are in the universal set, but they are not in the given set. And of course, the answer will be nothing but, so this is set of 1, 2, 3 down to 20. This is 1, 2, 3, 4, 5. So A complement will actually be from 6, 7, 8 down to 20. It's as simple as that. So these are the numbers that are in the universal set, but they are not in the given set A. Hence, it is called A complement. Okay, next question. Now, next thing to be done under this I is to now find A complement intersection D. First of all, you now ask yourself, what is set D? Set D is actually set of 2, 3, 5, and 7. Now, their intersection of this set and this set will simply mean what this set and this set have in common. And of course, this set have 2, 3, 5, 7. And in this case, now there is no 2 here, there is no 3 here, there is no 5 here. There is 6 here, but there is no 6 here. So what they have in common is just 7. So both of them have 7 in common. Therefore, let me just say that I part of the equation is equal to 7. Okay, that one is just as simple. So this one is nothing but 7. Okay, next question is II says, let me just clean this. So please make sure you take down the notes. Take down the notes. Now, II says C complement, relative complement of C, then all intersection D. Very important. So first, let us find C complement. C complement is, now again, what is set C? Set C is 2 and 3. So C complement will be the set that is in the universal set, but not in set C. And of course, the sets that are in the universal set, but not in set C, are nothing but 1, 4, 5, 6, down to 20. Very important, because now it's more like taking out 2 and 3 from here. 2 and 3, take it out. So, because remember what complement of a set is, the sets that are in the universal set, but not here. So it means that anyone that is in the universal set and also here, take it out. So 2, 3 is in this given set, 2, 3 is also in the universal set. So I take out 2 and 3. So after 1 comes 2, 3, take out 2 and 3, then comes 4. That's why I have this 4 here. Then 5, 6, 7, 8, down to 20. All right, so this is nothing but my C complement. So over here, let me find now. Next, since I've gotten my C complement, let me now take the relative complements of C complement and C, which will now give me C complement minus C. Okay, so this is C complement. Look at it here. Then set C is nothing but this. Now, taking the relative complement of these two sets will mean, now, of course, another name for relative complement also means difference of sets. All right, so taking the difference of these two sets will be this set and this set. Now, I'm going to take out what both of them have in common and leave or write out only the answers that is only in the C complement. Let me say it again. Take out what this set and this set have in common. Take what they have in common, take it out, then write only the answers that is in the first set, which is this. Okay, so, and of course, if you check carefully, they do not have anything in common. So since they do not have anything in common, it will mean that the answer of this and this will still be this, which is nothing but 1, 4, 5, 6, down to 20. Very important. Okay, sorry, let me write it more clearer. And of course, I hope you understand what this dot 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 means. The dot 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 is just there to account for the numbers I omitted. It's just there to account for the number omitted serially. That's what it means. Now, next thing to be done as far as this question II is concerned is to now find the whole of this. Now, I've gotten C complement minus C, all right, to now be this. So I'm going to take the intersection of this now and the set D. Therefore, C complement minus C intersection D is going to be what? So this C complement minus C is actually this, then D is actually this. So I will now ask, what does set D and set this have in common? If you watch carefully, this has 2, 3, there is no 2, 3 here. 5 is here, 5 is here, 7 is here, 7 is here. So they have, this one has 5 and 7, so I also have 5 and 7. Remember, 7 is also included here, even though I didn't write it out. These 3 dots mean accommodates that. So they have 5 and 7 in common. All right, so II is nothing but 5, 7. Very, very important. Okay, so let me clean it and quickly solve I part of it. So ensure to take the notes. Very, very important. So you can rewind the video as many times as you want to take the videos. To take the notes more clearer. Okay. Now the I part of the question says A complement union C complement. Very important. So what I'm going to do now is first find A complement. A complement. What does it mean? So first, what is set A? Set A is nothing but 1, 2, 3, 4, 5. Now, complement again means what is it that is in the universal set but not in the given set A? So if you watch carefully, the set U ranges from 1 to 20 and set A now ranges from 1 to 5. So it will mean that A complement will actually be from 6 to 20. 6, 7, 8, then down to 20. This is nothing but A complement. Then what about C complement? C complement again, first, what is set C? Set C is 2 and 3. So, and the universal set, now, set C complement will be what is it in the universal set that is not in the given set C. And the only thing there is C complement is nothing but 1, 4, 5 down to 20. I hope I'm right. Yes, because take out 2 and 3 here, take out 2 and 3 here. So you now have 1, 4, 5, 6, 7, 8 down to 20. Okay, so this is A complement, this is C complement. Therefore, A complement union C complement will now be what? Now, of course, what union of a set means is writing out all the elements in these two sets. Write out all the elements present in these two sets, but do not repeat any one that occur twice. Very important. So if you watch carefully, I have 1, 4, 5, then down to 20 here. I have from 6 down to 20 here. So I'm going to write out all the elements here. So writing out all the elements here and here without repeating anyone will actually be from 1, then leave 2 and 3 because 2 and 3 is not here. 2 and 3 is not also here. So from 1, I will now have 4, now have 5, have 6, have 7, have 8, down to 20. All right, so this is actually 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So in this case now, we've gotten A complement union C complement. So that will be the answer for the I part of the question. All right. So it's actually 1, 4, 5, 6, 7, 8, 9, down to 20. All right, so this is just it about question I. Okay, now let's quickly tackle the next question, which is the IV part of the question. IV part of the question. Please do well to take the notes. Very, very important. Okay, the IV part of the question, we now have, so it says B union into C minus D. Okay, first let us look for C minus D. All right, now the set C is nothing but 2 and 3, and set D is nothing but 2, 3, 5, and 7. So now looking for C minus D, we simply, because the first set here is set C mentioned. Okay, so C minus D will be what both of them have in common, take it out, and now write what is remaining in the first set mentioned. And of course, if you take what both of them have in common out, it will now mean that set C has nothing again inside of it. Therefore, C minus D will actually be empty set or null set. Very important. Then, therefore, B union into C minus D will be what? Let's see. Because now, set B is actually 0 and 1. So the union of these two sets, the union of this and this will simply mean write out all the elements in the two sets. And since C minus A has nothing, it means that this will actually be this, which is 0 and 1. Very important. Therefore, IV is nothing but 0 and 1. Okay. Now, finally, the V part of the question. Let me clean this. I always love solving this thing up so that you can see more clearer. Okay. Now, the V part of the question says A intersection C close, then union D. Very important. So A intersection C, first let us look for it. A intersection C is what? A intersection C. So talking about A intersection C, set A is 1, 2, 3, 4, 5. Now, and set C is actually 2 and 3. So what does set A and set C have in common? So if you now watch carefully, they have, this one has 2, 3, this one also has 2, 3. So A intersection C is nothing but 2 and 3. Very important. Therefore, A intersection C union D will now be this set plus this set. What does this set and this set? Now, not really what does. This set D and this set A intersection C, write out all their elements, but do not repeat anyone that occurs twice. So the answer will actually be 2, 3, 5, and 7. Alright, so that's the answer. So finally, the part of the question is actually 2, 3, 5, and 7. Alright, 2, 3, 5, and 7. Okay. But what if? Okay, so this is just the final question under that. Now I want to add one more question under this, even though the one I'm going to add now is not given here. What if we're given another one? Let me just say VI now. VI. What if question VI says that we should find, or let me even write it here. Let me clean this. So, but please take down this one. This is the answer for the V part of the question. Now let me give you VI part of the question very quickly, so that you can, let's balance it. Let's wrap up with this one for this number 5. Now, if we are given A intersection, or rather A union D close union into A minus B close. So if we are asked to find this, what are we going to do? First, let us find for A union D. Let's look for A union D. Looking for A union D, first set A is nothing but this and set D is this. So taking the union of these two sets, the answer will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes. A union D, 1, 2, 3, 4, 5, and 7. Remember, writing out all the elements without repeating anyone that occur twice. Now again, A minus B. Now A minus B will now be take out what A and B have in common, then write only the elements that is remaining in set A. Okay, so on the strength of that, what are we going to have? So this is set A and this is set B. So take out what both of them have in common and write out only the answer that is remaining in set A, which is the first set mentioned. So both of them they do not have 0 in common, but they have 1 in common. So the answer will now be 2, 3, yes, 2, 3, 4, 5. 4, 5. And that's all. Therefore, this union this. Therefore now, A union D union A minus B will now be what? So writing now, the union of these two sets will now be, write out all the elements the two sets have without repeating anyone that occur twice. Therefore, the answer will now be 1, 2, 3, 4, 5, and 7. Okay, so that is it for this particular one. 1, 2, 3, 4, 5, and 7. So thank you for staying tuned to this very moment. We are going to be seeing in the next part, which will be part 4 now. All right, so this is question number 5. In the next part, we are going to be seeing question number 6. So thank you. Don't forget to click on that red subscription button if you have not done so. Like this video, comment, share your observation on the comment section below. Let me know your observations. All right, so thank you. Bye for now.